Painite is one of the rarest gemstones in the world. It was first discovered in Myanmar in the 1950s, and until 2001, only 3 crystals were known to exist. Since then, additional discoveries have produced many more specimens, but facetable material remains very rare. Painite has a distinctive reddish-brown to deep red color, often with hues of orange. Painite contains calcium, zirconium, boron, aluminum, and oxygen. Painite crystals are typically hexagonal and can exhibit transparency to translucency. They have a Mohs hardness of 8, making them relatively hard and durable. Their refractive index ranges from 1.787 to 1.798, contributing to their brilliant luster. Painite is incredibly valuable due to its rarity and beauty. High-quality painite gemstones command astronomical prices in the gem market. Myanmar remains the primary source of painite, although very few crystals are found each year. Painite is the rarest gemstone in the world and one of the most unique minerals on Earth. Known for its striking orange-red to brownish-red color and distinctive crystal structure, it was first discovered in Myanmar, formerly Burma, in the 1950s. This complex borosilicate mineral has the chemical formula Cas9-pentadecooxygen monoborate and has captivated mineralogists, collectors, and gem enthusiasts alike due to its beauty and scarcity. Only a few hundred painite crystals have ever been found, most of which are quite small, with only about 24 being of gem quality. The largest painite crystal discovered measures just 2.5 centimeters in length. Its extreme rarity makes painite one of the most expensive gem minerals in the world. Scientific classification of painite. Painite is classified as a borosilicate mineral. It belongs to the pyroxene group of minerals, which are nesosilicates. Nesosilicates are a type of silicate mineral that contains only one type of tetrahedral, CO4, 4-unit. Painite is a rare mineral, and it is the only known mineral that contains both boron and zirconium. Why is painite so rare? Here are some additional reasons why painite is so rare. The chemical composition of painite is unique. The conditions required for painite to form are very specific. The temperature and pressure need to be just right, and painite is the only mineral that contains both zirconium and boron. These two elements do not normally associate with each other in nature, so it is very rare to find them bonded together in a crystal. Painite is found in very small quantities. The crystals of painite that have been found are typically very small, often measuring only a few millimeters in size. This makes it difficult to find enough painite to cut into a gemstone. Painite is often altered by other minerals. The crystals of painite that have been found are often altered by other minerals, such as rutile and hematite. This can make it difficult to identify painite and can also reduce its value. Limited geographic occurrence. Painite has so far only been found in a handful of locations globally, primarily in Myanmar. Properties of painite. Composition. Cas9, Bo3, 015. Painite belongs to the borate mineral class, with a unique combination of calcium, zirconium, aluminum, oxygen, and boron atoms arranged in a specific crystal structure. This composition contributes to its rarity as zirconium and boron rarely occur together in the necessary quantities for painite formation. Color. Red, brownish-orange, orange-red. Trace elements like chromium and vanadium within the crystal structure are responsible for painite's fiery hues. Unlike some gemstones with a single dominant color, painite can exhibit variations within its color range. Transparency. Transparent to translucent, the clarity of painite can vary. Transparent stones allow light to pass through completely, showcasing the full depth of color, while translucent stones allow some light passage, creating a more diffused appearance. Transparency is often linked to the presence of inclusions, which can affect light transmission. Luster. Vitreous. Painite possesses a vitreous luster, resembling the glassy shine of high-quality glass. This luster adds to the gemstone's brilliance and desirability. Crystal system. Hexagonal. Painite crystals typically belong to the hexagonal crystal system, characterized by a threefold rotational symmetry axis. However, some crystals can exhibit an orthorhombic system with a different internal arrangement. Streak. White. When scratched against a streak plate, painite leaves a white powder residue. This property helps gemologists differentiate painite from other red gemstones. Hardness. 8 to 8.5 Mohs scale. Painite boasts an impressive hardness rating on the Mohs scale, making it highly resistant to scratches and abrasions. This exceptional hardness, comparable to some sapphires, allows painite to be used in jewelry applications. Cleavage. None determined, painite does not exhibit a preferred direction of breakage, unlike some minerals that cleave readily along specific planes. This lack of cleavage can be advantageous for faceting painite into gemstones. Fracture. Conchoidal. When painite does break, it typically fractures with smooth, curved surfaces resembling a seashell. This conchoidal fracture is a common characteristic of many glassy materials. Habits and forms. Short prismatic or rounded grains. Painite crystals are not particularly diverse in form. They usually occur as short, prismatic shapes within the hexagonal system. In some instances, rounded grains can also be found. The growth environment and available space influence the specific crystal habit. Density, specific gravity, around 4.01 to 4.03 grams per cc. Painite is denser than most common rocks but lighter than many metals. This specific gravity value helps in identification and can be measured with specialized equipment. Tenacity. Brittle. Despite its impressive hardness, painite can be brittle under forceful impact. This means it can chip or shatter if struck with significant force. Careful handling is recommended for painite gemstones. Solubility. Insoluble, painite is highly resistant to dissolving in water and most common acids. This makes it a relatively stable gemstone for jewelry use. Magnetism. Not magnetic, painite does not exhibit any magnetic properties. This characteristic can be helpful in distinguishing it from certain minerals that may be attracted to magnets. Fluorescence. Weak reddish or yellowish. In some cases, painite can exhibit a weak fluorescence under ultraviolet light, appearing faintly reddish or yellowish. This fluorescence is not a defining characteristic but can be an interesting additional feature. Pleochroism. Subtle color change. While not as dramatic as alexandrite, some painite crystals exhibit a subtle pleochroism. This means the color may appear slightly more reddish in daylight and brownish under incandescent light. The viewing angle can also influence the perceived color. Refractive index. 1.787 to 1.816. The refractive index is a measure of how light bends as it passes through a material. Painite's refractive index is relatively high, contributing to its brilliance and fire. Inclusions. Painite crystals can sometimes contain inclusions, which are foreign materials trapped within the gemstone during its formation. These inclusions can affect the transparency, brilliance, and overall value of the stone. Painite with minimal inclusions is generally more desirable for faceting into gemstones.